The star scarab Guju, a red incredibly colossal monster found in the grand array of Orion, has long captivated stargazers and cosmologists alike because of its sheer size and splendor. Assuming bug juice were put where our sun is, it would stretch out to the orbit of Jupiter, demonstrating its enormous size regardless of being located around 642 light-years from Earth. Its vastness makes it potentially one of the most breathtaking stars visible to the UNI. Actually, Betelgeuse has shown odd behavior like astonishing darkening and enlightening cycles, which many investigators believe signal that the star is nearing the end of its life. The notable physicist Brian Cox recently made a striking statement that bug juice is on the verge of a stunning effect, expected to occur within the next 14 days. This event, known as a supernova explosion, will mark the end of Betelgeuse's life. However, it will provide an incredible opportunity for scientists to study one of the most puzzling, powerful forces and quirks in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the astronomical radar for many years, but its recent, unpredictable changes in brightness have ignited speculations that it is preparing for a massive explosion. When a star like Betelgeuse reaches the end of its life, its core implodes under its own gravity, leading to an immense explosion that releases a massive amount of energy, radiation, and tremendous material into space. Betelgeuse's upcoming explosion is expected to be a Type 2 supernova. This type of cosmic impact occurs when the core of a massive star collapses. The core collapse triggers the release of neutrinos and radiation, creating a shock wave that destroys the star. The explosion will be so brilliant that it might be visible from Earth without telescopes, potentially even outshine the moon in the night sky for weeks or months. While such an event would typically be catastrophic if it occurred near Earth, Betelgeuse's distance of about 642 light-years means that although the explosion will be noticeable and dramatic, it will not pose any threat to life on our planet. Nevertheless, the event promises to reshape how we understand supernova and other immense cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the sun in its entire lifetime. Betelgeuse's explosion will not only be a spectacular galactic display, but also a significant moment for science. Researchers are eager to witness this fascinating event from its earliest moments, using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to gather as much information as possible. When bug juice explodes, it will emit a wide range of radiation from visible light to gamma R. One of the key features of the supernova will be the flood of neutrinos, the elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion, due to their ability to pass through almost anything without being affected. Observatories like Japan's Super Cameo, Candy, and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in tracking Betelgeuse's final moments. The explosion will also offer crucial insights into the formation of heavy elements. When stars explode, they produce and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give scientists a clearer view of this element creation process, which is vital for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is unlikely to negatively affect Earth, it will interact with our planet's atmosphere and magnetic field. In fascinating ways, the energy burst from the explosion, specifically the emission of astronomical rays and charged particles, could lead to more intense auroras, expanding the regions where the northern and southern lights are visible. While these powerful beams might affect satellite communications and some technology on Earth, the disturbances are expected to be minor and brief. Perhaps one of the most astonishing aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment for months. Betelgeuse is expected to be the brightest object in the night sky, potentially even visible during the day. This event will captivate not only professional researchers, but also amateur astronomers and the general public, sparking renewed interest in space science and the universe. Scientists have long speculated about Betelgeuse's death, but Brian Cox's recent statement adds urgency to the matter. Observatories worldwide are preparing to monitor every stage of the supernova, and the data collected will be invaluable, potentially transforming our understanding of stellar evolution, supernova, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of stellar distances and offer a unique opportunity to measure how energy from such an explosion travels through space by observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars. Astronomers will gain a clearer understanding of the size of the universe, and the event will also offer a once-in-a-lifetime opportunity to investigate dark matter and how it might influence the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, doesn't emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, especially the way that massive stars contribute to the creation of the elements necessary for life. Supernovae are crucial cosmic events responsible for dispersing heavy elements throughout the universe, elements that ultimately form new stars, planets, and even living things. By studying Betelgeuse, scientists will gain valuable insights into how these elements are made and spread. The social significance of Betelgeuse's explosion is also crucial. For centuries, people have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the Orion constellation will spark philosophical reflection on the transient nature of the universe. In some cultures, such divine events have been interpreted as omens or signs of grand transformation. Betelgeuse's explosion might evoke a mixture of awe, fear, and wonder as people from all walks of life witness the death of a star. This magnificent event is likely to reignite interest in space exploration and stargazing, bringing more people into the quest for knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the supernova. This democratization of science will unite people across the globe, all watching and recording the same immense phenomenon from their unique vantage points. Betelgeuse's explosion is not only a remarkable event, but also a stepping stone for future exploration. The data gathered from the supernova will inform how we study other stars, especially as we venture deeper into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernova is crucial as humanity looks to extend its presence in the solar system and beyond. Moreover, the explosion will reignite interest in the search for extraterrestrial life. Supernova are fundamental for spreading the building blocks of life like carbon and oxygen across the universe. By studying Betelgeuse's explosion, researchers can gain a better understanding of how the building blocks of life could spread to other planetary systems and possibly spark life elsewhere in the universe. The approaching blast of Betelgeuse is set to be one of the most significant galactic events in recent memory. Its supernova will provide an abundance of scientific data, enhance our understanding of the universe, and undoubtedly dazzle people around the world. Betelgeuse's death will mark the end of a giant star, but it will also represent the ongoing cycle of creation and destruction that governs the universe, reminding us that from death, new stars, planets, and even life itself can arise. As we prepare for this monumental event, the world will eagerly watch the night sky, awaiting the moment when one of the universe's most powerful forces bursts into view for both scientists and stargazers alike. Betelgeuse's final journey will be awe-inspiring as Betelgeuse approaches the final stage of its life. One of the more speculative yet dazzling possibilities associated with its impending explosion is shedding light on some of the universe's greatest mysteries: dark matter and dark energy. These elusive forces are believed to account for most of the universe's mass and energy, yet they remain poorly understood. Some speculate that supernova like the one expected from Betelgeuse could hold the key to unlocking some of these mysteries. Supernova release enormous amounts of energy and radiation, and some researchers believe these powerful forces could interact with dark matter in ways we can observe. One interesting theory is that dark matter exists as faintly interacting massive particles. WIMPs. If WIMPs exist, their interaction with the energy produced by Betelgeuse's supernova could provide clues about their nature. Such a discovery would be groundbreaking, providing the first direct evidence of dark matter, a mysterious phenomenon that has puzzled scientists for years. Moreover, there is potential for Betelgeuse's explosion to provide insights into the nature of dark energy. Dark energy is a mysterious force driving the accelerated expansion of the universe. Understanding its role in cosmic evolution is one of the biggest challenges in modern physics. Betelgeuse's explosion could offer indirect evidence of dark energy's effect on cosmic depth, as supernova are thought to be influenced by the universe's expansion. Observing how Betelgeuse's supernova spreads through space could provide vital information to help scientists figure out how dark energy affects astronomical events and impacts the universe's large-scale structure. As Betelgeuse's supernova near, astronomers are preparing for one of the most anticipated cosmic events of the century. The explosion will offer a unique port to observe the final stages of a massive star, providing insights that could have implications far beyond our current understanding of stellar life cycles. While scientists expect the dramatic display of the supernova, they are also refining methods to study the aftermath of such an explosion. One area of focus is the formation of a neutron star, or possibly a black hole in the remnants of Betelgeuse. A neutron star is the dense core left behind after a massive star like Betelgeuse undergoes a supernova explosion. These compact objects, which can have a mass greater than the sun packed into a volume no larger than a city, are a key focus in astronomy. If Betelgeuse forms a neutron star, it will provide an unprecedented opportunity to study the behavior of matter under extreme conditions neutron stars are also known to generate strong magnetic fields and are sometimes seen as pulsars emitting regular bursts of light. The formation of such a celestial remnant could provide crucial insights into the fundamental physics of extreme gravity and the behavior of matter at incredibly high densities. If Betelgeuse collapses into a black hole, instead it will be another major breakthrough for researchers studying the formation of these mysterious objects. Black holes, which are regions of space where gravity is so intense that not even light can escape, have been the subject of fascination and theoretical research for many years. Observing the formation of a black hole from a nearby star like Betelgeuse will help scientists refine their models of black hole formation and better understand the role they play in the universe. Additionally, it could provide new ways to observe the event horizon, the boundary beyond which nothing, not even light, can escape, offering further insights into the nature of black holes. Another major consideration is how Betelgeuse's explosion will contribute to our understanding of cosmic rays. These high-energy particles, which are produced in events like supernova, can travel vast distances across the universe, while some cosmic rays are detected by observatories on Earth. Others have been difficult to study due to their sporadic nature. When Betelgeuse explodes, its supernova will generate a tremendous amount of high-energy particles that could provide scientists with an opportunity to study cosmic rays in greater detail. This could improve our understanding of how cosmic rays interact with the interstellar medium and what they might mean for space travel and technology on Earth.